Hello and welcome to the intro video for the XNA Drum Game series. My name is Zach Parrish, and with me is Mr. Logan Frank.
How's it going?
And what we're going to be doing in this video is giving you a brief overview, kind of an in-a-nutshell glance, at all of the different things you're going to see inside the XNA Drum Game series. Woohoo! So, Logan, why don't you talk to us a little bit about the XNA Drum Game series in general? What is our end goal? What are we doing?
Well, the end goal is a simple rhythm game that is focused on drumming.
Okay.
The end result is going to be a game that will allow us to bring up songs and play those songs using a variety of drum controllers. We'll be able to use primarily the Rock Band drum sets.
Now, you just said the Rock Band drum sets. Now, when you say rhythm game, are you talking something like Rock Band?
It will be similar in nature.
Okay.
The idea that you'll have notes scrolling across the screen and you have to hit those notes at a given point in time is going to be the core concept for the gameplay.
Gotcha. That's what I was looking for. Like, if somebody had never heard of the concept of rhythm game, what could they expect to see on the screen when they play? And it's essentially a series of notes that are going to scroll across, and you're going to be required to hit some sort of an input, be it a controller tap or a key press or a drum strike, right at a specific interval based on what note pops up.
Exactly. Yeah.
Okay. So now, how are we going to actually go about this? Is this going to be like, hi, we're going to write a drum game and just jump right in and start coding it?
Well, there's a few concepts we need to address first. So the overall video series is going to be broken up into 3 projects.
Ooh, this sounds like I should be taking some notes. So let's go ahead and do that. So the XNA Drum Game is going to be broken into 3 projects. Now, what are those projects?
Well, we're going to have 2 conceptual primers, which will address things like sound engines and music engines.
Okay.
And then the 3rd project will be the drum game itself.
So that was, what, sound engine?
And music engine.
And music engine. And I have such great handwriting. Do you see that? That looks like a letter M, doesn't it? And music engine. And then from those, I guess after those, we're to the 3rd project, which would be the drum game itself, right?
Exactly.
Okay. So why don't we just give everybody a quick rundown of what they're going to see in each project? We'll just start at the beginning, and when we get to the end, we'll stop. So let's talk first about the sound engine.
All right. The whole idea here with the sound engine is based on a specific problem we're going to have to solve.
Okay.
And that problem is the fact that we need to have very low latency in the audio inside of our game.
I'll put it another way. Our problem is lag.
Now, when we're using XNA's sound system, which is based on XAudio 2,
okay,
we have a little bit of lag that is introduced simply due to the heavy processing pipeline that it uses.
Now, you say that you've got a lot of lag. Does that mean that XNA's native sound system is bad and that we shouldn't ever use it?
No, the amount of lag that's given is generally imperceptible in pretty much every kind of game other than a music game. Meaning, and if you're in a shooter or any other kind of game, the idea is that sound is used to augment things that you're seeing on screen. You have a sound action to go with something that may be arbitrary visually.
I gotcha.
And in the case of a music game, the whole point is we're going to be focusing on timing. In order to play the game well, you need to focus on timing, very specific timing, and that tends to magnify any kind of lag problem.
Makes it more perceptible.
Exactly.
So in most cases, the lag that you run into in XNA's sound system, which again is derived from XAudio 2, is not necessarily a problem. You would never see it. But because in a music game you're putting everything against a set rhythm, it becomes a little bit of an issue. And in a lot of cases, this is going to be manifested by the time it takes to hear your actual drumstick hit your rubber pad for the drum kit, and then actually come back through as some sort of a sound that feeds back from the computer.
Exactly, and it also comes down to personal preference as well, depending on what you're used to. For example, if you're a professional musician, then a small amount of lag would probably drive you up the wall.
Sure.
If you're more laid back and you play rhythm games just as a, just on the side, you're not
You're
too
a gamer.
then they may not be a problem. Again, it all depends on your own personal preference as far as the amount of lag that is acceptable.
All right, well, we've established that the problem here is lag or latency, however you want to look at it. So what is our solution?
Well, what we're going to do is we're going to use an entirely different sound API where it's available.
Okay.
And what that means is if we are on the PC platform, we have access to direct sound. And using direct sound, we have a much lighter pipeline that it uses, and the result of that is much less lag.
I'm going to put it a different way. A sound engine that uses multiple APIs.
There you go.
Or that can use multiple APIs.
And therefore, the whole point of the sound engine itself is simply to give that layer of abstraction that allows us to utilize multiple APIs, to where you could say, on the outside, we're given options. We use direct sound, we can use XNA, but on the inside, we can play audio in the same manner, and it's the sound engine that figures out what should be playing our sound.
Gotcha. So the sound engine's its whole job is to say, all right, well, are we on the Xbox or are we on the PC? And then to sort out which system we're going to use based on that.
Exactly. That way, when we're inside our game coding, we don't have to worry about that. We can just say, play sound whenever we feel like it, and then it's up to the configuration of the game itself to say, the sound engine needs to play using direct sound or XNA, depending on what platform we're on.
Now, are we going to be limited to just using direct sound or XNA?
Actually, no. We're going to design the sound engine in a modular fashion, which would allow us to develop additional sound engines if we ever wanted to add support for more devices, more APIs. For example, if you were familiar with coding for a specific professional audio API.
Like a really low latency pro audio API?
Exactly.
Yeah.
If you were familiar with those kinds of systems, this sound engine would allow you to create a module that would let you use your own faster
That's pretty
API.
slick. So that's the whole idea of the sound engine. We're basically focusing on the problem of lag or latency, and our solution is to create a separate sound engine that's going to allow for different APIs based on different applications. If we're on the PC, we're going to use direct sound. If we're on the Xbox 360, we're going to use XNA because we have to. So that means on the Xbox 360, there will be a little more latency because we can't get around that issue. But on the PC, we can. And in doing so, we're going to have developed a system that is modular and will allow for other APIs if the user wanted to create them.
Yep.
Cool. So that's our first project, just the sound engine. Now our next project we mentioned is a music engine. Now, what are we focusing on when we develop a music engine?
Well, the primary thing we're going to need to deal with is timing.
So you could say that our problem here is really all about timing. Now, try to go into a little more detail on that. What's so important about timing that we need to worry about it?
Well, if you think about it, in music, a lot of the timing deals with subdividing notes, meaning you have one note will be held for a certain duration, and another note will be held for half of that duration. So it's basically you take a core timing system, but you subdivide that based on the note that you actually need to play.
And that core timing system, in terms of music, is generally calculated in
beats per minute.
Beats per minute. So our problem is timing. So in the music world, we have beats per minute.
Now and we want to stick with that terminology. When we go to express our song and say that it has a tempo, we want to express that tempo in beats per minute.
Okay.
Now in XNA, there is no existing functionality that will convert that over to an actual span of time used by XNA.
So we try to hand XNA a beats per minute value, and XNA basically gets sad and says, I don't know what beats per minute means.
Exactly. And if you try to use the number directly, then you simply won't get beats per minute.
So our job is going to be to explain beats per minute to our programmer. Set up a system basically that allows us to use a beats per minute based system.
Exactly. We'll create a conversion routine where we can feed in beats per minute, and that will in turn set the XNA timing engine to run at a specific time, giving us beats per minute.
So the overall upshot will be that we'll be able to set tempo in a way that relates more directly to music, as opposed to setting our music rate by saying, well, we're going to play our music back at a rate of 1,024 cycles per second, which doesn't make any sense to anybody.
Exactly. Or try to migrate the idea of musical timing into seconds to say that we're going to run assign second values to notes, which doesn't work because you end up changing timing.
Right.
Anyway.
It's all about bringing everything into the musical world, which is beats per minute. Now, we're going to be doing this in a couple of different stages, right?
We've actually got, it's really two main stages that we need to address.
Okay.
The first of that is the metronome itself.
Okay.
The idea here is, using the conversion routine we were talking about, we establish a scenario where we request a time in beats per minute, and the end result is a metronome of sorts that causes a given number of updates per minute.
So where a metronome, like, okay, your wooden wind-up metronome that hopefully you've all seen, little wooden pyramid with a little stick that ticks back and forth, again, tick, tick, tick. Its job is to output a sound at a specific rate of ticks per minute. In our system, we're gonna basically do the same thing, but instead of actual beats or like those sounds per minute, we're actually gonna do program updates per minute.
And again, that simply makes sense since the sound will come further down the line. There's other things we need to do. We need to do stuff like see if the user has hit a note. We need to draw notes on screen. And the idea is to make this metronome be the core timing system of the whole game. That way everything will be synchronized against it.
Well, we could just, once we get this programmed in, we could just feed this in and say, I want you to play back at 208 beats per minute, and we would end up getting 208 game cycles every minute, right?
Yep, exactly.
Okay. Now, from there, that's only half the battle, because at that rate, for most games, you're going to need more cycles than that. And
not to mention, for most music, you need to be able to place more notes, or rather, you need to be able to place notes in between beats.
That's exactly right. Between every single beat, you can have a lot of different notes, where your rhythm could just be tick, 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 tick. Your actual, the sound could be. I get carried away with that. But so we've got the first half, which is the metronome. So what's the second part?
That would be note placement.
Okay.
It's the idea of subdividing the time given to us by the metronome to give ourselves enough accuracy to actually place notes on a timeline of sorts.
Gotcha.
So it's all about further subdivision of time.
So we'll have those initial game cycles coming out of the metronome, and then we're going to take that and divide that up. So in effect, we'll end up with a lot more cycles in between each beat.
Exactly.
And that will allow us to place notes along a timeline in between beats. And once we have that, we've got musical rhythm. And we have a sound engine right there, or a music engine actually, right there, because we have our beats that we can program in to set our tempo. We can place notes along the timeline generated by that. We're done.
And that's it. Now we have the ability to represent music and have that music timed correctly by the game engine.
We have in effect solved the problem of musical timing. So
exactly.
That's going to be our second project, is building this music engine that really addresses this problem of timing and takes the idea of computer time and converts it to a music time of beats per minute. Now, once we have that out of the way, we are down to the third and final project, which is the programming of the actual drum game. Now, we talked about this briefly in the beginning of this video. Basically, this is going to be a game that is similar in function to games such as Rock Band or Guitar Hero, where you're going to see a staff of notes that are going to slide across the screen in maybe one of different directions, and as they reach a certain point along the timeline, you are going to do something. You're going to hit a button, you're going to tap a drum, you're going to press down on a controller. You're going to perform some sort of function in time with what you see on the screen, which is what makes this a rhythm game. Does that about sum it up?
Yeah, it follows the basic pattern of Rock Band in that you are given notes, you have to hit those notes in time, otherwise the bad result happens.
Now here's just a real quick thing. That's kind of how it's like Rock Band. How is it different from games like Rock Band or Guitar Hero?
Well, it's going to be different in the way that sound is actually generated. What I mean by that is instead of having a dedicated music track that plays along with you, instead the individual drum hits are going to be the units that generate sound.
Okay.
Where this differs is in a game like Rock Band, you have a track that is continuously playing, and the moment you miss a note, the track gets muted.
Right.
And then begins playing again when you begin playing correctly again.
That's like when you're sitting there, you're playing Rock Band and you're wailing away on the drums, and you're that really cool solo part, and you miss a beat, and suddenly the drums switch off and you don't hear anything. That's not because you're suddenly just not playing and therefore not hearing, though. That's kind of the effect. The idea is that drum track is playing the entire time. It just kind of gets muted when you fall out of sync.
Right, it can go in and out depending on how you play the game.
Right. It's on a separate track. Now, our system is different than that because on our system, you're actually playing a note. And because you played that note, you get sound playback.
Exactly. And a lot of that is also due to the fact that as a startup gamer, you may be lacking a licensed song set for any given music, and you may also be lacking not only a song set, but one that has been divided by track. For example,
Right.
this game focuses on drumming.
Exactly.
And you may not have the facilities or contacts necessary to get versions of a specific music track where the drum track is broken out from the rest of the music.
Which is where the development of games such as Rock Band and Guitar Hero takes as long as they do, because they've got to take that licensed music apart track by track and put it into the game in such a way where the drums are separate and the guitar is separate and the vocals are separate, so that as you play or don't play each instrument, those parts can come in and out.
Right, and since the note patterns have to be composed simply for gameplay purposes, in our case, reusing that information for music playback is the obvious solution.
All right. Well, so that at least illustrates the difference between our game and already created licensed games such as Rock Band and Guitar Hero. So you understand that going in. Now, what are some of the key topics that we're going to be addressing as we go through the drum game? Why do people want to learn how to program this game?
Well, we're going to need a set of subsystems just to get ourselves up on our feet as far as the game itself is concerned. Mm-hmm. Really, this is another reason that the music and sound concepts were addressed before the game itself.
Yeah.
And that is because we want to address this in the fashion of a complete game.
Okay.
What that means is we're going to have supporting systems such as configuration, input handling, screen management, and so on.
Actually, you just said like the magic word there that I like to go ahead and point out. This will not be a tech demo kind of video. We're not going to be just saying, oh, well, here's some basic engine components, and then here's kind of how they interact. Now go make a game. We're actually going to show you the process of making an entire playable game out of this. That's a critical aspect that sets this apart from some of the other projects that we've done in XNA, where a lot of those were just, they're more or less glorified engine demos. This will be an actual game that we're going to produce.
Right, because we're going to need an amount of structure in place to allow us to put together more components in order to make a complete game.
All right, well, let's talk about some of these components that we're going to be putting into place.
Well, the first of these is game configuration.
Ooh.
And what we're talking about here is the idea of using a configuration file to gain game settings.
Like a config file.
Exactly. This is in contrast to earlier games done in the XNA series, where the configuration was basically just a set of fields, a set of properties inside the game. The downside to that system was the fact that in order to change any given setting, one would need the source code and need to be able to recompile the game.
So you couldn't go through like with some of the older games and just change their resolution to get a bigger game without having to recompile it.
Right.
I see.
So what we're going to do is we're going to set up a configuration system that will read in information from an XML file. So in this case, we could have something like config.xml, and even if we didn't have the source code to the game, we could still open this config file in a text editor and change any of the settings we want, and then those settings will in turn be loaded when the game loads.
Very cool. So I'm taking notes down. So no need to recompile when changing settings. And that's awesome. Having that config file, I can already see that as being tremendously useful. So what's another one of these key topics?
Well, the next topic we'll need to address is input handling.
Input handling. Okay.
Now, we're going to go a little bit beyond just the basics of simple button state detection. We're actually going to want to address input configuration. We're going to want our input system to work in conjunction with the configuration system and allow us to bind various inputs, be they things like keyboard keys, controller buttons, drum pad, drum heads, or what have you.
So just like how on some games, without mentioning any in particular, where you can open up that config file and say, bind the X key to note 5.
Exactly. We'll be able to put similar lines, similar entries into the config file, and thereby we can change the input without having to recompile the game.
Gotcha. Which would allow, it seems like the next logical step from that is that would easily allow you to handle differing inputs from multiple different devices.
Right. We will take that concept and we'll implement it in a modular fashion.
Okay.
And this will allow us to add support for multiple input devices more easily.
I gotcha. That's very, very cool. All right, well, what comes after that? Once we have input handling, what's your next thing to attack?
All right, moving on, we have screen management.
Screen management. Now, you explained this to me earlier outside the videos, and I thought it was the coolest thing in the world, and I'm going to try not to just go off on a rant about it. So why don't you try to tell us what management is, and I'll try not to override you.
All right, the idea here is that when we have a more complex game, generally, we're looking at different parts of the game at different times. What I mean by that is you'll often have a menu system to go along with the game itself.
Right.
So you'll have a series of menus that will allow you to do things like select the mode of game you want to play. In our case, they might also allow you to select a song. And in our case, in order to make these screens easy to change as the game progresses, we're going to make it so that everything is a screen.
Okay, hang on. I'm going to say it a slightly different way. And I'm going to look at this and notice that my spelling is terrible while I do it. So, management. I got so carried away that I just totally forgot about my spelling. The screen management system is a way to take our game, and I have to draw a picture for this. So here's our game. We're going to divide it into a whole bunch of little sub-games. And each one of these sub-games is a screen. Now, that's kind of a loose way to look at it. But by flipping in between each one of these screens, that's how you're going to experience our game. So, for instance, one of these screens will contain the actual playable game. That's going to have our staff marching by, and we're going to hit the little notes as they go along. Then there will be a totally different screen whose only job is to select what song we're going to play. And then a whole nother screen. His only job is to show us our end score once I get up there and I absolutely suck at playing the game. And another screen that's kind of our title screen that tells us what mode we're going to play in. And the whole idea is by flipping between all of these screens in a particular order, we're thereby presenting the game to the player.
Exactly. It also makes it easier for us to code the individual screens, since at any given moment, we as the programmers can work just from the standpoint of a screen. We don't have to worry about anything the game does adversely affecting the main menu. We don't have to worry about anything the song selection does adversely affecting the score screen.
That's right. So the game itself is really a culmination of these little sub-games or screens that we're just kind of flipping between. So it's a really cool way to look at the program. So once we have screen management in place, and I'm sorry, I just think that's so awesome. I love talking about it. So what comes after that?
The next thing is the overall music management inside of the game itself.
Now this sounds daunting.
Well, really, this breaks down into a few more pieces. I mean, this is the heart of the game. Obviously, with a rhythm game, being able to control, play, and use music is going to be the driving force here.
Okay.
This is going to be addressed in three main phases. We're actually going to write a set of classes that will represent notes and songs. Basically, you've got a note, you're going to want to have some properties on it. You're going to want to be able to tell what time it is, maybe what drum track it plays on. And you're also going to want to have songs, which are going to be compositions of notes. They'll have other properties like what tempo should they be played at, and so forth.
Sure.
And let's see, moving on from here, we're going to need to implement those classes in such a way that will allow us to play back music. Because just having notes and songs in place is great for representing music, but we need to combine these with timing in order to get playback.
Now that's where we're going to run back into the things that we handled way back up here with our music engine, where we solved the problem of timing.
Exactly. We'll actually have to go and utilize some of the conversions we came up with to let us take our songs and end up driving the game at an appropriate rate so that those songs are played back correctly.
Gotcha. So once we have those implemented, what's our third phase?
The third phase will be interaction.
Okay.
And that is going to be the level at which the game is allowed to look at input and to decide if that input was hit at the appropriate time to hit a note.
So in simpler terms, the notes will march across the screen and the game can now look for when the player strikes their drum pad or whatever it is they do.
Exactly, and then the game will be able to make a decision and say, was that hit close enough to a note to count as a hit, or is it going to be far enough off that it counts as a miss?
Or did the player just fail and now they get nothing? I like it. All right, so there's our music management system in a nutshell. We have our songs, we're implementing them with timing so that we can play back music, and then we're going to check and see whether or not the player can actually play the game or if they should go home and maybe take up knitting. So what's our next thing?
All right, next thing is going to be the visual effects system,
Okay.
which is a very fancy term for the fact that we would like there to be a particle explosion every time a note is successfully hit.
Okay.
It simply adds to the visual feedback in the game if you see an effect based on what you're doing instead of simply hearing it.
I'll write it like this: note explosions.
And the idea here is to simply provide a sprite-based explosion every time a note is hit.
Boom. In all these different pieces. So boom. Yeah, when you hit a note, it's just going to pop. And all these little things will fly out. So we're going to show how to code that effect. And what's left? What else we do?
Well, all of these systems combined are really the core of the gameplay.
I mean, at this point, you have a game.
Yeah, you could stop at that point, and you would have a playable game.
Mm-hmm.
Now, we want to go a little bit further and add a few more modes. The first of which is going to be a free play mode.
Let me write it down this way. We'll have additional modes. And the first one will be, you said free play mode?
Free play mode.
How's that work?
In essence, it's a note recorder. The idea is that the game almost plays in reverse of the normal gameplay, where normal gameplay consists of you are presented with notes, and you have to hit them in time. Hitting them causes them to disappear.
I gotcha.
This is kind of the opposite. You're presented with no notes from the onset, and as you hit drums on your respective drum controller, you'll get notes added to the screen. So basically you're set, you begin with an advancing timeline, and as you hit notes, they appear. And of course you hear the sound accompanying them. It's almost like a live composition mode.
So basically, you play...
and the game records.
And game records. Now, is this going to get saved out to something you can use later?
Yes, we will give the option of saving the result of any given free play session to a file, to a song file, in case you want to load it up later for gameplay.
Awesome. Now, are there any other modes that we should know about?
One other mode, and that is going to be edit mode.
Edit mode. All right, so how does edit mode work?
Well, edit mode is basically a song editor. The idea here is that you'll be given precise controls to allow you to place notes on the timeline in order to compose songs.
Okay.
It will also allow you to load up existing songs if you wish to make changes.
So while it's not really the case where the free play mode is kind of like analog recording, where it's just going to kind of march across and you just play whenever you feel like it. This allows you to go like by each little time tick and place the notes exactly where you want them.
It's more analogous to writing sheet music. If you had a simple pen and paper and you just wanted to write the notes down, this will give you similar functionality. You'll be given with a static, non-moving timeline, and you can drop notes down at your leisure, though you will be given playback abilities so that you can play your song, see what it's sounding like, and very quickly go back and forth to.
Sounds like a pretty fun game, because we can sit there and we can play the classic version where a song plays and we just try to actually play the notes that come across, or we can record our own stuff and see if our friends can play it. Now, there's a question. Like, if we'd record something with either free play or edit mode, can that be applied to the actual game so we can try our hand at playing it later?
Yep, absolutely. We'll be able to take a free play session, so to speak, turn it into a song, and play it back in normal game mode. Or we'll be able to, like, let's say, you're playing in free play, you're not really paying attention, all the notes are kind of all over the place.
Yeah, it sounds like I'm playing.
If you wanted to structure that and make that into more of an official sounding song, you could actually take the result you record in free play, load that up in the editor, and clean things up. Space all the notes properly, and save that back out, and then you'd have a nice professional sounding song that you can play with your friends in the normal game mode.
Awesome. Yeah, I can see all sorts of ways, like play like a game of horse, where you sit there and you play out some sort of rhythm and then hand it off to your friend and see if they can play it back. Could be a lot of fun. So there's all of our different modes. Is there anything else that the code itself is going to cover?
Well, without delving too deep into the hows.
Well, yeah, this is kind of an intro, so we should keep things fairly simple.
Really, that's going to be the main things encompassing the game. The subsystems that we'll need and the modes that will be provided.
Okay. Well, some of the other things that we're going to be, we have to sort of look at is game presentation. Because this is not just a tech demo, because this is a full game, we're actually going to be implementing a full suite of graphics. So it's going to look a little nicer than your basic Hello World app. It's got some things to look a little sharper. We also have to talk a little bit about game flow. As we mentioned earlier, the game is going to be screen-based, where you've got different screens that handle different aspects of the game, and it's important to have a solid understanding of how those screens are going to be switched between. When you first start the game, of course, you're going to want a title screen where you can choose a different type of mode. Then what screen do you see after that? Maybe it's the gameplay screen based on the mode you choose. As soon as you're done playing, what do you see then? Where do you go after that? We're going to kind of talk about how you jump between each one of these screens and how the flow itself is going to be handled. Now, this game is going to be coded using a lot of different inputs, different input devices. What kind of input devices are we going to be using, Logan?
Well, we're going to be supporting the keyboard, obviously, just as kind of a debug device. Since this is being developed on a PC, you have a keyboard in front of you, and it makes it very easy to run testing sessions if you're allowed to use keyboard input.
Okay.
Now, for actual gameplay, we're going to be supporting the Rock Band 1 drum set.
Okay.
the Rock Band 2 drum set.
So Rock Band 1 and 2 drum sets. Now, there is a difference between those. The Rock Band 2 drum set has like some extra pads on it, doesn't it?
It does. It has a certain way that you have to decode the inputs to accurately read all of the separate drums and cymbals that it provides.
I gotcha.
So it will actually be addressed as more of a bonus topic, meaning that we will primarily develop for keyboard and Rock Band 1 controller. Throughout the development of the core game, Rock Band 1 and keyboard are going to be the base input devices.
Okay, well here, let me write it a different way so there's no confusion. So these will be our primaries.
So those are our core inputs.
Yeah. Well, okay, well, yeah, we'll use your terms. That's cool. So our core inputs. Now, just as a side note, because we're doing a Rock Band 1 controller, this also implies your basic Xbox controller?
It does. So if you wish to press the A, B, X, Y buttons on the controller instead, you're obviously free to do so.
Yeah, that kind of comes along with it. Now, apart from that, kind of as to the side, we'll be doing the Rock Band 2 controller.
That's right. This is done also to demonstrate the modularity of the input system, and that is after we have a nice game in place, we can go back and add support for more devices.
Just as a note, I want to mention, we're going to be implementing this with the use of the Ion Drum Rocker.
That's correct. We're actually going to be demonstrating this on an Ion Drum Rocker.
Right. So if you just have the Rock Band 2 set, as far as we know, they're one and the same, and they should function exactly the same way. But if they don't, for some strange reason, what we're actually going to be using is the Ion Drum Rocker.
Right, and the core of the way you're going to decode the inputs is going to be the same between them. We're just noting the fact that if you're missing a specific, like let's say if you're missing or you have an extra input, there may be very minor differences between the two.
Right.
But I mean, the core class, the core code that will be generated here will work on both.
Okay. So there you go. So now, once we get the Rock Band 2 controller in place, we're going to do something that is very special. And I don't even want to spill it. Logan, you tell them what we're going to do.
Well, one final device that we're going to add support for is a general MIDI device, meaning anything that the primary goal here is to allow support for electronic drums.
Yeah.
But in doing so, you'll be able to use pretty much any device that has MIDI connectivity.
Gotcha. So if you have your really cool, like, actual electronic drum kit that you tour with your real band on stage with, you'll be able to plug that in as long as it has MIDI support. If you have a MIDI keyboard, you can use that. Or really any musical device for which you have some means of getting MIDI output, you'll be able to use that to play this game.
Yep, that's correct.
So that is a look at everything we're going to be discussing throughout the drum game videos. Just again, as a really quick recap, we're going to be breaking the whole thing up into 3 base projects, 2 of which are really just kind of primers to get you in tune with some of the concepts that we have to utilize. The first of which is a sound engine that allows us to switch between different APIs for separate applications. So we'll be using XNA's native sound API when we're on the Xbox 360. When we're on the PC, we're going to be using direct sound instead because of its lower latency. It'll also be designed in a modular fashion so that if you want to incorporate some APIs of your own that maybe you're familiar with coding with, you'd be more than welcome to do that. It's going to easily integrate into the system we'll design. The next exercise we're going to go through is the music system, or the music engine. And really this addresses the problem of timing, where a computer's time and the way time is counted in the music world don't necessarily correlate. So we're going to create a beats per minute engine that allows us to specify a certain number of beats per minute, get certain number of game cycles every minute, and to place notes along a timeline. And that's really that's the core of creating a rhythm game right there, because you need to be able to specify beats per minute, and that's a language that musicians understand, and to be able to place notes along the way so that you can play those back. Once we have those 2 concepts down, that's when we go in and we start actually coding in our game, which is going to handle a lot of different things, such as using config files, dealing with multiple types of inputs, screen management, music management, visual effects, and then creating some different gameplay modes as well, such as the free play or record mode, the edit mode for going in and placing notes with some form of precision. And just as an additional, we're going to be handling multiple input devices here. The keyboard and the Rock Band 1 controller, which also extends to the Xbox controller, as well as the Rock Band 2 controller, and in our case manifested with the Ion Drum Rocker. And finally, we're going to show how to add support for MIDI devices. So I'm sure this is going to be just. I'm excited. I can't wait to get into this. I'm so excited about actually coding this game and seeing it develop, and I hope you are too. Logan, is there anything else that we want to talk to people about?
I think that covers it. Really, that's the basis. That is the game plan from this point.
All right. So I think with that, we are ready to go ahead and start jumping into these projects. Thanks a lot.